The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on and take a look at the first part of section 5.8. But before I do that, do any of you have any questions over last night's homework that you'd like me to do?
Not so far.
All righty. Well, then we'll take a look at section 5.8. The first thing I want to do actually is to review some rules that we haven't necessarily talked about this quarter. They're basically in the previous math class, Math 85, or perhaps a high school beginning algebra class. And they are rules that have to do with exponents and properties of exponents. The first one, let's say we have something like x to the 5th power divided by x to the 3rd power. And we want to reduce or simplify this expression. If we expanded it, we'd have 5 factors of x in the numerator divided by 3 factors of x in the denominator. We could go through and reduce x over x to 1 over 1, x over x to 1 over 1, x over x to 1 over 1, and what we end up with is x squared. Well, this is fine and dandy, but what if we had x to the 714th power divided by x to the 212th power? We wouldn't want to expand this out and write 714 x's over 212 x's and reduce them all down. That would be ridiculous. So instead, let's look for a shortcut, a rule. And the rule is this. To get from here to here, we take the base raised to this power minus that power. So in general, if I have x to the m divided by x to the n, this becomes x to the m minus n. So x to the 12th divided by x to the 9th would be x to the 12 minus 9 power, or x cubed. Y to the 17th divided by y to the 7th would be y to the 17 minus 7th power, or y to the 10th power. So we have that rule. Do you have any questions about that rule? Because we're going to be using it. All right. What if we have x squared divided by x to the 5th power? What if the exponent in the numerator is smaller than the exponent in the denominator? Well, following that rule, we get x to the 2 minus 5 power, which is x to the negative 3 power. So it still works. However, let's look at this expression a different way. Let's go back and let's expand it the long way. 2 factors of x on top divided by 5 factors of x on the bottom. We reduce it down 1 over 1, 1 over 1, and we end up with 1 over x cubed. Well, if x squared divided by x to the 5th equals that, and the same thing equals that, then doesn't it make sense that these two should be equal? So if x to the negative 3 power equals 1 over x to the positive 3 power, what are we doing? We're taking the reciprocal of the base, 1 over the base, raised to the positive exponent. So we put it on the other side of the fraction bar and change the sign of the exponent. So for instance, let's say I have y to the negative 7th power. That would be 1 over y to the positive 7th power. Let's say I have x cubed over y to the negative 2 power. That would be x cubed times y to the positive 2 power. Moving it upstairs. We can also take something on top and move it down below and change the sign. Let's say I have, well, I guess we've been doing that. Let's say we've got something on top that's negative and something on the bottom that's negative. Well, the bottom one moves to the top and has a positive exponent. The top one moves to the bottom and has a positive exponent. In general, we say a to the negative r equals 1 over a to the positive r. Okay. One more example. Let's say we've got x cubed over x cubed. Well, if we use that original rule we looked at, that would be x to the 3 minus 3 power, which would be x to the 0 power. But if we take x cubed divided by x cubed, isn't that just 1? Which means that x to the 0 power equals 1. So we've got these three rules. We've got, let's see, a power divided by a power with the same base. You're going to subtract the bottom exponent from the top. If you've got a base raised to a negative power, that's 1 over the base to a positive power. And if you've got a base raised to the 0 power, that's equal to the number 1. All right. Any questions before we go on? So that's the backstory. Now let's take a look at some of these problems from section 5.8. And as I say, part 1. So let's say we've got a to the 12th power divided by a to the 8th power. Well, that would be a to the 12 minus 8th power, or a to the 4th power. Any questions about that example? Okay. Let's say we've got 22b to the 9th power divided by 6b to the 6th power. Well, first of all, we could reduce 22 over 6 to 11 over 3 by taking a 2 out. And then this would become what? B to the 9 minus 6, which is 3. So we get 11b cubed over 3. This reduced down to 11/3. This reduced down to b to the 3rd power in the numerator. All righty. Let's say we've got this situation. Negative 4x cubed over 16x to the 5th. Something I neglected to mention, typically, unless it says otherwise, when we write a final answer, we want all of our exponents to be positive. So in this situation, I can reduce the negative 4 over 16 to negative 1/4. I could reduce x to the 3rd over x to the 5th to x to the, 3 minus 5, or negative 2 power. But then we would take this and move it downstairs and make it positive. So our final answer would be negative 1 over 4x squared. This becomes negative 1 on top. This becomes x squared in the denominator. All righty. Let's take a look at this example. 3y cubed z divided by 18y z to the 6th power. 3 over 18 reduces to 1 over 6. Y cubed over y to the 1st power becomes y squared over 1. And z over z to the 6th becomes z to the 1 minus 6, or z to the negative 5 power over 1. So now I've got 1 times y squared z to the negative 5. So y squared z to the negative 5 power over 6 times 1 times 1. But then I could take the z to the negative 5 power, put it down below, and make it z to the positive 5 power. So again, our answer has positive exponents. Any questions about this example? All righty. Now we're going to take a polynomial and divide it by a monomial. And the way we're going to do this is we're going to split it up. We're going to take each term in the numerator and divide it by the monomial term in the denominator. So then 8x over 4 reduces down to 2x, and 4 over 4 reduces down to 1. So 8x plus 4 divided by 4 is 2x plus 1. Any questions there? Now, we can't go in and reduce that or that. We have to split them up first. These are terms in the numerator, and we can't reduce out if we have terms. So we need to split them up like this and then reduce each individual fraction. All righty. B squared plus b cubed minus b to the fourth power, all divided by b to the fourth power. So again, we have a polynomial divided by a monomial. So we're going to take each term in the numerator and divide it by the term in the denominator, and then go back and reduce each separate term. B to the second over b to the fourth would be b to the 2 minus 4, or b to the negative 2 power, which would then become 1 over b squared. B cubed over b to the fourth would be b to the 3 minus 4, or b to the negative 1 power, which would be 1 over b to the positive 1 power, and I don't need to put the implied positive 1 exponent. B to the fourth over b to the fourth would be b to the 0 power, which is 1. So there's our final answer. Alrighty, let's do this problem. 12r to the 15th power minus 48r to the 12th power plus r to the 10th power minus 18r to the 8th power. That whole thing divided by 6r to the 10th power. So again, I've got a polynomial divided by a monomial. I'm going to take each term in the numerator and divide it by the denominator. Notice I brought the sign down. Okay. All right. So 12 divided by 6 is 2 over 1. R to the 15th divided by r to the 10th would be r to the 5th. So we get 2r to the 5th minus 48 over 6 is 8 over 1. R to the 12th divided by r to the 10th is r to the 12 minus 10, or r squared. So we get minus 8r squared plus r to the 10th over r to the 10th would be r to the 0, which is just 1. So we get plus 1/6 minus 18 over 6 is 3. R to the 8th over r to the 10th is r to the 8 minus 10, or r to the negative 2 power. So we get minus 3, but then r to the negative 2 on top moves downstairs to become r to the positive 2. And so that is our final answer. Notice again, all the exponents are positive in the final answer. All right, any questions? So now we're going to look at examples of polynomials divided by polynomials. Again, this that we just did is a polynomial divided by a monomial. When we take a polynomial and divide it by a polynomial, the process changes. So let's take a look at this example. It says divide x squared plus 8x plus 12 by x plus 2. All right, before we do that, I actually want to go to the next page for a minute, and I want to review long division and just basic arithmetic. Let's say we've got 485 divided by 3. So the 3 goes on the outside, that's the divisor. the 485 goes inside. That's the dividend. You've got the dividend in the divisor. And then we say what? 3 goes into 4 one time. 3 times 1 is 3. What do we do now? Anybody?
We subtract.
Before you subtract, what do?
Oh, we times.
You draw a line. Sorry. And then you subtract. 4 minus 3 is 1. If this number is smaller than that number, then you know you've done it correctly. If it's larger, then you have to go back and take more out. So then we bring down the next number. 3 goes into 18 6 times. 18, we draw a line, we subtract 0. Bring down the 5. 3 goes into 5 once. And then, now, way back in basic arithmetic, when you first started out, you would have written 161 R2, meaning remainder of 2, okay? Then later on in life, when fractions were introduced, you would have said 161 2/3. So you would have taken the remainder over the divisor. Do you remember doing that? And then maybe later you'd have decimals and all that, but this is the form we're going to be using, okay, for the remainder. Okay, so let's go back up here. So x plus 2 goes outside. X squared plus 8x plus 12 goes on the inside. Now, some of the things are the same and some of them are slightly different. So let's go through the steps. Once I have both the dividend and the divisor in descending powers, which they are in this case, I'm going to focus on the leading term inside and the leading term outside. I'm going to take the leading term inside divided by the leading term outside. So I'm not going to worry about all the other stuff, just those leading two terms, okay? X squared divided by x would be what? X, right? Okay.
Yeah.
So I'm going to take that and put it up here in the x column. Then I'm going to take this x times the divisor. So x times x plus 2, which gives me x squared plus 2x. You still with me?
Mm-hmm.
Okay. And we're going to write that here. Oh, I did this wrong, didn't I? That should be x squared plus 2x. So we're going to get x squared plus 2x. But then we're going to draw a line and we're going to subtract that quantity from what's up above. Now, in just basic arithmetic, you're just subtracting a single number, so that subtraction sign is attached to that whole single number. But here, the subtraction sign needs to be distributed to the whole stuff in parentheses, the whole stuff. That's very grammatically correct. So what I'm going to do is I'm going to change it to addition of the opposite, which would be the same thing as distributing the subtraction sign. Okay? You all right with this?
So you just flipped everything positive to be negative.
And everything negative would be positive, right? Distributing and subtraction sign changes the sign of everything inside. Now it's addition. We're going to add up the columns. X squared plus negative x squared is 0x squared. Okay? And 8x plus negative 2x would be plus 6x. Okay? We all right with that?
Yeah.
So now I'm going to start over. I'm going to focus on the leading term. Oh, wait, I need to bring down the next term. All right, just like you bring down the next number. I'm going to focus on the leading term inside divided by the leading term outside. So I'm going to have 6x divided by x, which is what?
6.
6, okay? And that's a plus 6, so that goes there. Then I'm going to take 6 times x plus 2. So 6 times x plus 2, and I get 6x plus 12, distributing the 6. I'm going to write that up here, 6x plus 12. Okay. Then I'm going to subtract that quantity from what's up above. But I'm going to change it to addition of the opposite. Adding up the column, 6x plus negative 6x is 0x, and 12 plus negative 12 is 0. So there's no remainder. So my answer would be x plus 6. So that means x squared plus 8x plus 12 divided by x plus 2 should equal x plus 6. How do you check your work? You take the quotient times the divisor, and you should get the dividend. So let's see, x plus 6 times x plus 2 is x squared plus 2x plus 6x plus 12, which is x squared plus 8x plus 12. It checks. So our final answer is x plus 6. Any questions on this particular example? All right, let's take a look at another one. This says divide x squared plus 5x plus 6 by x plus 2. So x plus 2 goes outside. X squared plus 5x plus 6 goes inside. All right. The inside and the outside are both in descending powers or standard form. So now I'm going to focus on dividing the leading term inside by the leading term outside. X squared divided by x would be x. And I'm going to put that over here in the appropriate column. Then I'm going to take that x times the divisor, the x plus 2. So I'm taking this times that. Distributing, I get x squared plus 2x. Okay. I'm going to take that quantity and write it up here, x squared plus 2x. I'm going to subtract it from what's up above, but I'm going to distribute the subtraction or change it into addition of the opposite, right? Okay. X squared plus negative x squared is 0. 5x plus negative 2x is 3x. Bring down the next term. Any questions? All right. We're going to take the leading term inside divided by the leading term outside. 3x divided by x, which is 3, and it's a plus 3. Then we're going to take the 3 times the divisor, the x plus 2, and we get 3x plus 6, which we're going to write here. But we're going to subtract that from what's up above, which will change to addition of the opposite. 3x plus negative 3x is 0. 6 plus negative 6 is 0. So again, we get an answer with no remainder. And to check our work, x plus 2 times x plus 3 should equal x squared plus 5x plus 6. X squared plus 3x plus 2x plus 6. X squared plus 5x plus 6. And it checks. All righty. Now let's take a look at an example where we get a remainder, in case you thought they all were going to come out nicely. Let's take 3x squared minus 8x plus 3 divided by 3x minus 2. So outside we've got the divisor, 3x minus 2. Inside we've got the dividend, 3x squared minus 8x plus 3. we're going to take the leading term inside divided by the leading term outside. So 3x squared divided by 3x. The 3's would reduce down to 1 over 1. X squared over x would just give us an answer of x. So that's going to go up here in the x column. Then we'll take that x times the divisor, the 3x minus 2, and distribute. 3x squared minus 2x. 3x squared minus 2x, which I'll write up here. 3x squared minus 2x. But I'm going to subtract that quantity from what's up above. But I'm going to change it to addition of the opposite. 3x squared plus negative 3x squared is 0x squared. Negative 8x plus 2x would be negative 6x. Bring down the next term, plus 3. Start all over. We'll take the leading term inside divided by the leading term outside. Negative 6x divided by 3x would be minus 2 or negative 2. So I'm going to write minus 2. Okay. Then I'm going to take the minus 2 times the divisor, the 3x minus 2, distribute. I get negative 6x plus 4. So negative 6x plus 4. I'm going to subtract that quantity from what's up above, change it to addition of the opposite. Negative 6x plus 6x is 0x. 3 plus negative 4 is negative 1. All right. So now I have a remainder. So I'm going to write the remainder over the divisor. So I'm going to have x minus 2 plus negative 1 divided by the quantity 3x minus 2. Okay. Now, there are a couple of different ways you could write this answer. You could write it this way, or you could write x minus 2 minus 1 over 3x minus 2. Okay. The book tends to do it this top way. Honestly, I don't remember off the top of my head whether WebAssign does it that way or accepts it either way, but you'll find out, won't you, when you're doing your homework. But be careful, don't overkill. Don't put a subtraction here and here, okay? So if it's so basically your answer plus your remainder. So if your remainder is negative, you're going to have a negative fraction here. But let's go with this way and see what happens. I think that's the way they do it in WebAssign. At least that's the way they do it in the textbook. All right. Any questions on this example? Okay. Let's take a look at another one. Let's say we've got 4x squared plus 6x minus 1 divided by 2x plus 1. So I'm going to have 2x plus 1 outside and 4x squared plus 6x minus 1 on the inside. Dividing the leading term inside by the leading term outside, we get 2x. So we put that in the x column. Then we take the 2x times the divisor, which is the 2x plus 1, and we distribute 4x squared plus 2x. We write that up here, 4x squared plus 2x. Draw a line. Subtract that quantity from what's up above. If I'm going too fast, let me know. Change that to addition of the opposite. 4x squared plus negative 4x squared is 0x squared. 6x plus negative 2x is 4x. Bring down the next term. So then we're going to take the leading term inside divided by the leading term outside, and we get 2, so plus 2. We're going to take that times the divisor, the 2x plus 1, and distribute. We get 4x plus 2, which we write up here. Okay. We're going to subtract that quantity from what's up above. Change it to addition of the opposite. 4x plus negative 4x is 0. Negative 1 plus negative 2 is negative 3. So I get 2x plus 2 plus a remainder of negative 3 over 2x plus 1. Okay. Be careful when you're changing signs. Make sure you cross out that previous sign so that when you go back to read it, you get the correct sign on the number. Make sure you can read your own chicken scratch. Any questions on this problem? All righty. Let's see here. Let's take a look at this question. X plus 2 divided into 3x plus 2x squared minus 2. So what are we going to do first of all here?
Take the x plus 2 and
We take the leading term, so the 3x.
Careful.
then you
Is it
divide
x plus
3x
2
by
over 3x?
x plus 2.
Is 3x the leading term?
No, it's x.
Yeah, take x and put it over 3x.
No,
No? Oh.
no. There's something wrong with this problem before we start it.
Oh, I see. The exponents are not.
Not in.
Ah, now we're getting somewhere. Yeah, the inside isn't in descending order, is it?
Nope.
No, okay. You were all going, what's he talking about? What's going on here? Okay.
Tricky.
So x plus 2 on the outside, 2x squared plus 3x minus 2. So
Yeah,
2x
minus.
squared is the leading term. So get it in standard form first. Tricky guy. Okay. Now we're going to take that divided by that, okay? So 2x squared divided by x would be 2x, which goes up there. Okay. Then we're going to take the 2x times the x plus 2, distribute 2x squared plus 4x, which goes here. Okay. Then we're going to draw a line and subtract. We'll change subtraction into addition of the opposite. 2x squared plus negative 2x squared is 0. 3x plus negative 4x is negative 1x. Bring down the next term, minus 2. Okay. So now I'm going to take what? That divided by that. What's negative x divided by x?
1, 0.
Negative x.
No. Negative
Is it
1. You said 1, you said 0, and somebody said negative x, but it's negative 1. Okay. You see that? Yeah, because it's got to be a minus 1 up there, not a plus 1. So you got to get the right sign. Okay, just like when you took your driving test, the officer said you have to do the right thing. When it says stop, you don't go zipping around at 80 miles an hour. Well, hopefully you don't. Okay, so now we're going to take negative 1 times the x plus 2, which is negative x minus 2. So that goes here. Okay. We're going to subtract that quantity from what's up above by changing it to addition of the opposite. Negative x plus x is 0. Negative 2 plus 2 is 0. So our final answer is just 2x minus 1. All righty. let's take a look at, you ready to go on?
Yes.
Okay. 3 plus 11x plus 10x squared divided by 5x plus 3. So what am I going to put on the outside?
5x plus 3.
Okay. And on the inside?
The inside would be 10x squared plus 11 plus 3.
11x.
There you go.
11x plus
There you go. Good job. Okay. All right. Awesome. Awesome. Here we go. So 10x squared divided by 5x is 2x. Okay. 2x times the quantity 5x plus 3 is 10x squared plus 6x. So we get 10x squared plus 6x. We're going to subtract that quantity from what's up above, changing it to addition of the opposite. 10x squared plus negative 10x squared is 0x squared. 11x plus negative 6x would be what? 5x. Bring down the next term, plus 3. And start all over again. Leading term inside divided by leading term outside. What's 5x divided by 5x?
1.
So that's plus 1. Good. And 1 times 5x plus 3 is 5x plus 3. And we're going to subtract that quantity from what's up above. We'll change it to addition of the opposite. 5x plus negative 5x is 0. 3 plus negative 3 is 0. So our answer is 2x plus 1. All righty. So tonight, you're going to work on the first part of section 5.8, which deals with reducing monomial fractions. And then if you have, remember the first, then after that, we looked at if you have a polynomial divided by a monomial, you split it up, each term in the numerator divided by the term in the denominator. But then if you're dividing by a polynomial, that's when you use this process, okay? So you've got two different processes going on there. If the divisor is just a single term, split it up and reduce each one. If it's more than one term, use this polynomial division process. All righty, I'll be back at 1:15 with an office hour. Should you have any questions? I'm going to go ahead and stop the recording.